Tool preparation checklist. Removing a damaged MOS. 1. Remove the rubber covers from all 4 sides of the battery. Then use a 2.5 mm internal hex screwdriver to remove the corresponding screws. 2. Flip the battery over and use a 2.5 mm Torx internal hex screwdriver to remove the screws at the connector area. 3. Carefully open the top cover. Disconnect the battery's positive and negative terminals, as well as the signal wires. Wrap the battery terminals securely with electrical tape to prevent short circuits. 4. Remove the screws securing the top and bottom covers. Separate the top and bottom covers and take out the thermal silicone pad. 5. Use tweezers and a flathead screwdriver to scrape off the black silicone around the MOS area. Then, clean any residue with a soft brush to ensure the MOS pins are clearly exposed. 6. Set the multimeter to continuity, buzzer, mode. Use the red and black probes to measure between the first pin of the MOS and the remaining pins. If the multimeter beeps, it indicates a short circuit in the entire row of MOS components. 7. After securing the bottom plate, set the hot air gun to 400 degrees Celsius and aim it at the short-circuited MOS to continuously heat it. Meanwhile, use a soldering iron to heat the pins at the tail end of the MOS. 8. After approximately 3 minutes of continuous heating, set the soldering iron to 380 degrees Celsius and gently pry the MOS to check if it has loosened. If it is still not loose, solder paste and solder wire can be used to assist with heating. 9. Once the rear pins are lifted, switch the soldering iron to the front pins of the MOS. After a short wait, push the front pins to fully remove the MOS. 10. After removing the entire row of MOS components, use PCB cleaning fluid to clean the solder pads. Ensure the pads are clean and free of debris. Installing a new MOS. 1. Apply a small amount of solder wire to the solder pads. 2. Use a hot air gun to heat the solder pads. While heating, use tweezers in your left hand to hold the new MOS, and use a soldering iron in your right hand to sweep over the pads, placing the new MOS into position simultaneously. 3. After installing the entire row of MOS components, use a multimeter to measure again. 4. Set the multimeter to continuity, buzzer, mode. Use the red and black probes to measure between the first pin of the MOS and the remaining pins. If a short circuit is detected, recheck the installation position of the MOS until the multimeter no longer indicates a short circuit. 5. After confirming there is no short circuit, apply waterproof sealant to the MOS pins and wait for it to cure. 6. Reinstall the repaired bottom board back onto the top cover and tighten the securing screws. 7. Remove the insulating tape from the battery terminals, reconnect the terminals to their original positions, and connect the corresponding signal wires. 8. Reinstall the top cover onto the battery.
Notes: 1. When removing screws, make sure the screwdriver is firmly inserted into the bottom to avoid screw stripping, which may result in inability to remove it. 2. After disconnecting the positive and negative cables, be sure to wrap them with insulating tape to prevent short circuits caused by contact between the terminals. 3. After separating the bottom board with the top cover, remove the corresponding thermal grease. If not removed, the thermal grease may melt during heating and take a large amount of heat away, making it difficult to remove the MOS. 4. When scarfing off the black silicone, pay attention to the small resistors around the MOS area. Do not damage them. 5. When using the heat gun and the soldering iron, keep the heat gun temperature at 400 degrees centigrade and soldering iron at 380 degrees centigrade. 6. The heat gun must continuously heat the MOS. When prying the MOS with the soldering iron, lift it gently. Do not apply excessive force to avoid damaging the solder pads on the board. 7. When replacing MOS, the entire row must be replaced. Ensure that all new MOS are from the same production batch. 8. During installation, make sure not to leave too much residual solder on the pads to avoid breaching between pins. 9. When replacing the entire row of MOS, check all are properly aligned and all pins are fully soldered in place.
Software operation. USB serial port update. Open the original debugging tool compression package decompression folder. Run the installation package, select the corresponding language, and click Next to enter the license agreement confirmation screen. Check the I agree and click Next. Enter the installation path selection page. Select the required installation path and click Next. Enter the component selection screen. Note: when installing the USB CAN tool for the first time, ensure that all the boxes are selected. If the following message is displayed during installation, the LabVIEW Basic Runtime Environment is integrated or installed. Click Cancel. Skip the installation of the LabVIEW Basic Runtime Environment. If the above interface is not displayed, it indicates that there is no LabVIEW Basic Runtime Environment in the system. LabVIEW Basic Runtime Environment plugin installation interface will show up. The installation program automatically enters the NI LabVIEW Runtime Engine 2011 SP1 operating environment to install. Insert the USB end of the CAN box. Right-click My Computer to open the management. Select Device Manager. Find the USB pop-up window just inserted. Right-click Update Driver. Select Browse My Computer to find drivers. Select the installation package download folder. Click Next. Wait for the search to finish. Install the upper computer software. Unpack the package. Open the application software. NJG001. Monitor R1.3 for viewing the basic information of the battery. JAU001. Upgrade R1.1 for upgrading the battery software and the firmware. There are two channels at the interface of CAN box, which are divided into CAN 1 and CAN 2. When in use, connect any channel and switch the corresponding resistance channel to the on end and close the other end of the resistance channel. View battery information and alarms. First of all, install the software you need to use in the computer, serial port driver. Connect the CAN box well. Pay attention to the wiring of the CAN box. Do not connect wrong. After the battery is connected, open the software NJG001. Monitor R1.3. Select CAN card as CAN Analy in the setting. Index as 0. Click Disconnect in the middle and select Device Remote Communication and Device Telemetry on the right. Check the alarm of the problem in the Device Remote message. The common alarm is low core, low charging temperature, high discharge temperature, low discharge temperature, large pressure difference alarm, connector over temperature alarm, MOS short circuit, CAN communication failure, 0 V tight charge, communication failure, discharge, communication failure, charging, SOC low alarm, short circuit protection, etc. Problem alarm lights up next to the corresponding problem. According to the specific alarm handling problem, the current solutions that can be solved by replacing the battery cover are low charging temperature, high charging temperature, high discharge temperature, low discharge temperature, MOS short circuit, CAN communication failure, SOC low alarm, short circuit protection, battery interface damage, light board is not bright. Click Device Telemetry to view the specific parameters of the current battery, such as single voltage, number of cycles, and total voltage. Click the basic information of the device to view the information of the battery manufacturer. Upgrade the battery firmware. Open JAU001. Upgrade R1.1. Select CAN card as CAN Analy. Index as 0, and click Connect. In the file path, select the firmware we want to upgrade. Click Start in the operation below and wait until the progress bar reaches 100%.